Chapter 3 is all about solids, liquids, and gases. In order to define solids, liquids, gases, and the fourth phase of matter, plasma, we need to examine their properties. So let's begin with solids. Solids are matter that have a definite shape and a definite volume. And you can see here that I've drawn this picture with lots of little circles demonstrating the molecules that are inside of a solid. In a solid, the particles are packed very closely together and they're fixed in one position. They are packed so closely together that they are locked in position and can only vibrate. There are different types of solids. The first type of solid is called a crystalline solid. And in a crystalline solid, the particles form a regular repeating pattern that creates the crystals, like in the quartz that you see here, and melts at a specific temperature. So examples of crystalline solids include salt, sugar, snow, and quartz. And you can see here the example of quartz, and then I drew this to show the regular repeating pattern of the molecules that are in quartz. They are particles arranged in a regular pattern. There also are amorphous solids, and in an amorphous solid, the particles are not arranged in a regular pattern, and they do not melt at a distinct temperature. They may become softer and softer, or they may actually change into other substances. And so examples of this are things like plastics, rubber, glass, and butter. You can see here in this image of butter that the particles are not organized in any kind of pattern and are, as you know from your experience, butter will become softer and softer as it gets warmer. The next phase that we are going to talk about are liquids. Liquids have a definite volume, but no shape of its own. The particles are packed almost as closely as in a solid, but these particles, when they're in their liquid state, are more loosely connected, and they collide with each other and move past one another. So one might say a fluid is a substance that flows. So what I've drawn here are particles that are very close together, almost as close as in a solid, but I drew these little arrows to show that they are sliding over each other and colliding. Liquids have specific properties, and one of those properties is the idea of surface tension. Surface tension is a result of an inward pull among the particles, molecules, of a liquid that bring the molecules on the surface closer together. So the molecules on the surface of a liquid are actually a little closer than the molecules that are underneath it. And that's what allows for, as in this image down here, of the insect that appears to be floating on the water, you can see the surface tension being demonstrated right there. It's able to land on top of the water because those molecules are a little closer together. Viscosity is another property of fluids. A liquid's resistance to flowing, depending on the size and the shape of the particles, as well as the attractions between the particles, is what viscosity is. So when you have a substance that is described with high viscosity, what we are describing is that that liquid flows slowly. Honey, molasses, these are both examples of that. So here I drew a turtle to remind myself that high viscosity means that it flows slowly. Low viscosity means that it flows quickly, things like water, and so I drew these arrows to show speed. Gas is another phase of matter. So a gas has no definite shape and no definite volume. It also is considered a type of fluid, and can be. In a gas, particles move freely in all directions to fill the space that is available, and they collide frequently. So here I showed all of these particles, and they're more spread out, but I have arrows pointing out to show that they're moving as this collides into the perimeter of what it's staying within, it will bounce back, it might hit other particles. The final phase that does not exist in many circumstances you will encounter on Earth is plasma. Plasma is common on the Sun and other stars, but it does not often occur naturally on Earth. We use it in things such as fluorescent light bulbs, however, so we will not be talking much about plasma. As we continue this lesson, we will begin to look at changes in states of matter.